So here a banana is thrown upwards. The mass of the banana M is 0.5 kg, and it is thrown at a velocity of 4 meter per second. So if we say u, that is 4 meter per second, and it reaches a height of 0.8 meters. So that's the height. We say 0.8 meter. So there is an air drag, and we have to find out what change does air drag cause in the mechanical energy of the banana earth system. So when we say mechanical energy, throughout this travel, if there was no air drag, what would have happened is mechanical energy would be constant. That means sum of the kinetic energy and potential energy would be constant. And what happens when the banana is thrown? At the moment when it is thrown with the velocity of u equals to 4 meter per second, let me write it here, u equals to 4 meter per second, it had a kinetic energy which would be corresponding to half mv square, and v becoming u, so that's 4. And at that point, since its height was 0, the potential energy would be 0, and as it is going upwards, its kinetic energy would be less. As its velocity would be less, it would decelerate because of Earth's gravitation, and its potential energy would compensate for that. So basically the kinetic energy would be converted into potential energy, and the potential energy will be, of course, mgh, which will correspond to its height. So what would happen if there was no air drag? When it reaches at that point, its velocity momentarily becomes 0, and then it starts coming down. So this way going up, this way coming down. And when the velocity is 0, that is when it has reached its maximum point, at that point we can calculate its potential energy, which would correspond to its height, which is its maximum height times its mass times g, and that would be equal to Ke would be equal to Pe, because at that time when it is at the maximum point, since its velocity is 0, its kinetic energy is 0. So all the kinetic energy is converted into potential energy. So again, the mechanical energy is still the same, because this is the kinetic energy with which it started, which is half mv square, half mu square. And when it reaches here, all that energy, initial kinetic energy, is converted into potential energy, and in between, kinetic energy is decreasing, potential energy is increasing, and when it's coming down again, potential energy is decreasing and kinetic energy is increasing, and so on. So here what happens, when it reaches its maximum height, all its kinetic energy is not converted into potential energy because of air drag. So what we will do to solve this problem, we will see that the potential energy that it has when it reaches its maximum height, it's still less than kinetic energy, and that will be the energy due to air drag. So let's calculate the kinetic energy of this in the beginning. So that would be half mu square, and half times 0.5 times 4 square, so that is 4 joules there. And when it reaches maximum height, so this is Ke max. At Ke max, P is 0, so the mechanical energy is this one, and this should be the mechanical energy when throughout, basically, without any other air drag or any other kind of energy loss. But when it reaches maximum height, the kinetic energy is 0. So all this potential kinetic energy should have been converted into potential energy, but let's see what happens. That is mgh. So we know m, same as before, of course, but h is given as 0.8, and when we do that, we can see that this is 3.92 joules, not 4 joules, bit less than that, and that difference is the energy lost due to air drag. So air drag energy, so I don't know how to write it, so energy due to air drag, maybe that will be Ke minus Pe, Ke max basically, and Pe max. because Ke max corresponds to the mechanical energy with which it started, and this is the mechanical energy at its maximum point, because at this point when Ke max, P is equal to max, Ke equals to 0, and here Pe equals to 0. So only that corresponds to the total mechanical energy, of course. So this is the mechanical energy with which it started, and this is the mechanical energy when it reaches its maximum height. So that difference is 4 minus 3.92, which is 0.08 joules, which can be written 80 millijoules.